Good morning, Veritas scientists. It's Monday, March 30th, 2020. Hope everybody had a good weekend. I got some fun soil stuff that I dug out of the ground. I dug it at the farm. I got some other cool things that I would like to show you. So I got soil from right next to a river and soil from at the farm. And we're going to kind of compare the two different types of soil today. So stay with us and we'll get to do that in a few minutes, all right? Thank you for joining us. Here we go. So on Friday, I hope you watched the experiment that Johanna and I did. We talked a lot about organic matter, being dead plants and animals and their waste that become part of the soil after they decompose. And organic matter is what's really, really good to have in soil. All right, that's what is going to get all the nutrients to the plants that they will need in order to grow. Okay, so plants need sunlight, they need water, and they also need nutrients. And those nutrients come from this organic matter, those dead plants and animals that have decomposed and become part of the soil. Then we talked about inorganic. They are not organic. They were never, ever alive. Okay, so inorganic matter are things like rock, sand, clay, and some other minerals, and we're going to talk about that a lot today, is inorganic matter. All right, so I left you a question here. It said, even though sand is not good for growing crops by itself, why would we want there to be some sand in the soil that we use to grow crops? Okay, first of all, we don't really have a choice of what is in the soil, all right? So it's not like they added sand to the soil down at the farm. It just happens to be there. But it's good to have a combination of it all, because if you didn't have any sand, then we would have some drainage issues, right? We would have problems with the water draining too fast, with all the water kind of draining in the same direction, kind of like a river would start and kind of take all of that, all the good stuff, all the nutrients, and will drain through too quickly. And it won't hold on to anything because it's all inorganic, right? None of it's going to soak in like pieces of organic matter like wood and rotting leaves and other things that have decomposed. That's going to hold on to some water, which will be able to feed those plants. But the inorganic matter, all that's sand, is completely inorganic matter, so it's not going to hold on to very much of the nutrients or water. So it's all going to kind of make its way through faster at the end of the day. All right? So here we go. Here's some different types of inorganic matter. These are all not alive. They were never alive. All right? So sand is the first one. Sand are tiny pieces of broken rocks and minerals. And it says alone, sand is not good for growing crops because it's loose and doesn't allow roots to hold on tightly, and it drains real quickly. And like we were saying, it doesn't hold on to those nutrients that we need to help grow plants. Okay, clay, number 2, is an earth material that is sticky when wet and hard when dry. And it's made up of very tiny particles. So the particles of clay are much, much smaller than particles of sand. Okay, and that causes them, when it gets wet, they all stick together, right? So that's really, really sticky, and it will basically puddle up the water. The water won't be able to get through it as well. So it says, by itself, clay is not good for growing crops because it causes water to puddle, right? Those particles are so closely packed together because they're so small, right, that it's going to kind of cause the water to puddle up on the ground, and it's going to drown plants. It's not going to be good for plants to be able to go through. And since those particles are so small and tightly packed together, that the roots are going to have a hard time getting into them to begin with. And we talked about that on Friday. Okay, so here's a new word you may have never heard. It's silt. So silt is an earth material. It's also inorganic matter. It's an earth material with particles that are larger than clay, but smaller than sand. So silt is kind of right in between the sizes of sand being bigger, clay are smaller, silt is right in between. So the particles are not as small as they are in clay, and they're not quite as big as they are in sand, they're in the middle. Okay, so it's found in soil also, and it's also known as sediment because it is found, silt is found near water, right? It's from the sediment that's settled down, it gets into water, and it settles down to the bottom, and then it creates this silt. Okay, so the soil that we have has a mixture of sand, clay, and silt, and we want a good mixture of that, but really, really importantly, those are all inorganic matter. What's really important is that we also need some organic matter. We need a good amount of this. Dead plants and animals, that is where the nutrients come from that these plants need in order to grow. All right, so I'm going to show you some different types of soil. Some are sandier than others. And we're going to kind of look at how there's a little bit of a mixture of these things in it. Okay, just in case I run out of time in the video, I want you to answer this question for today. I will go over this tomorrow. It says, how did a mixture of sand, clay, silt, and organic matter all become part of the soil at the farm? Where did they come from? Okay, how did those different parts of organic matter and then the inorganic matter as well, right? How did those all become part of the soil at the farm? Where did they come from? All right, so here we go. Let's go check this out. Here's Charlie. He's whining a little bit, so I'll let him out in a minute if he is. Okay, first of all, I found this soil right next to the river in my backyard. Okay, look at the color of it. It's sand. Lots of sand in here. There is some silt, I'm sure, mixed in here. Up at the top, closer to where this moss is growing, up on the top, you can see it's a little bit darker brown. Okay, so there's lots of organic matter, but look, it's only a thin layer at the very top of the organic matter. And then the rest of it, you can see it's really sandy in color. You'll be able to tell when I put it next to this other soil that I'm going to show you in a second how sandy that is. But you can see the color being really light, like the color of sand. All right, and you can even see the difference between here and there. Okay, I know, Charlie. Hold on a minute. Okay, so check this out. I got this down at the farm. So this is a corn stalk. Right, so this would be the stem, and then those are the roots that reach down under the ground and grab onto the soil. And you can already see the difference, right? Look how dark that soil is right where the corn stalk came out of compared to that sandy soil, right? See the difference between it? Okay. So here's another one. It shows the root system and how the roots all come down and allow this corn stalk to be able to stand up real strong and real tall so it doesn't blow over in the wind, or if there's rain it doesn't fall over, or if animals walk by it they're really anchored in tightly. Okay, so I thought that was cool. I wanted to show you that. Okay, so here's a piece of corn that I found from last year's crop. You can see some of it looks like it got eaten by a deer. I see deer prints out there all the time, so they're still feeding on this. But I also wanted to show you how it's decomposing, right? See how black it is down here, right? There's bacteria, there's funguses eating away at it, and it is soon going to become part of the soil, especially as it gets warmer and the bacteria builds up. It's going to really decompose this pretty quickly. So I thought that was cool too. I know, Charlie, I know you got to go up, but you got to give me a minute, all right? Here's another piece of corn. This I found on the ground. So again, this is all organic matter. This is all going to decompose, like you can see. Look at the green stuff growing off of it, and the black and it's purple, and it's nasty, right? It's getting decomposed, and this will become part of the soil that we're going to look at in this bag in a second. Okay, so pretty cool that all of that will decompose, and that'll make this really strong soil. Okay, so now let's get into this bag. Okay, so I literally dug a hole in the ground right underneath where the corn was growing, and I pulled out all this soil. Okay, so let's get a look at it. There's a little piece of corn right there. Okay, look at the difference between the sand next to the river and the sand in the soil, right, at the farm. All right, let's see if I can get them real close, right? Look at the difference in color. Okay, so near the river, it's real sandy. Not very much is going to be able to grow in this sandy soil because you can see how loose it is, right? It's loose. It's not going to hold roots very well. You can see there's some roots coming down from the moss, right, as it comes through right here. There's some roots I just pulled on. Okay, so it's going to be able to grab a little bit, but also there's more of that organic matter at the top. It's darker. Down here, this is all going to fall apart. It's not going to be able to hold in there. The plants, no plants are going to be able to grow in this because it's just going to fall apart, and it's not going to anchor them into the ground. Okay? Now look at this nice dark farm soil, right? This is the good stuff. Look, there's a mix of all. There is some sand in there. You can see a little bit of the lighter color is the sand, right? There's probably some clay mixed into here. Okay, there definitely is. So there's clay, there's some sand, and there's also some silt in here. And we could really only tell the difference. Sometimes you can tell by the color, but if you looked under a microscope, you'd really be able to see the different sizes of the different particles. Clay are super, super small. Sand are a little bigger than all of them, right? And silt is in the middle when it comes to size. Okay, but if you look through the soil, there are all sorts of twigs, and there are roots. And there's lots of inorganic matter, right? You can even hold it like this, which allows plants to be able to grab onto this a lot better. So they'll be able to anchor in, right? These corn stalks are able to anchor right into this soil real well, and they get lots and lots of nutrients from it. You can even see the difference between the two, right? So this farm soil is going to be excellent for growing crops. Okay, so I'm going to go down the farm and find some clay, because I saw some yesterday when I was riding my bike, but it was raining out, so it was much too wet to see. I'm going to go tomorrow, and today, and I'm going to go find some clay, so you can really see the color of the clay, and I'll be able to maybe make a video and show you how it puddles up the water, and you'll see that where the clay is, there's going to be lots of big puddles of water. All right, so tonight, hope that was cool. I thought that was really cool, so I hope you enjoyed that. I want you to answer this question. How did a mixture of sand, clay, silt, and organic matter all become part of the soil at the farm? Where did they come from? And we'll talk about that tomorrow. Have a great day. Thanks for watching. See ya.